Sorry, the screen sharing. Okay.
Yes. The first step towards getting somewhere is to decide you are not going to stay where you are. A very warm good evening to one and all, and welcome to Droid 2.0. Droid, a technological event that can help you take a trip to a robo planet, which is hosted by Robotics and Automation Society of IEEE FISAT SB in association with IEEE R.A.W-Roboticists chapter. Droid 19 was a grand success where participants from all over India had participated. It motivated and inspired many young minds to bring out their innovative ideas. As part of Droid 2.0, we have a 5-day interactive virtual talk series with world's 5 top roboticists, R.A.W-Robotics around the world. Today, we are here for the chapter 2 with one of the eminent speaker, Dr. Juxi Leitner, co-founder and managing director of LYRO Robotics with us. So now let me invite 𝗧𝗹𝗺𝗲 for the welcome speech.
Small steps in the right direction can turn out to be the biggest step of your life. Warm evening to you all. It's an honor to be gathered here with this group of amazing people. Myself, 𝗧𝗹𝗺𝗲, welcome you all on behalf of our whole family of IEEE FISAT SB to R.A.W, Robotics Around the World, hosted as a part of Droid 2.0 by Robotics and Automation Society IEEE FISAT SB. R.A.W is a 5-day interactive virtual team series with the world's 5 top roboticists. Today, we have the very distinguished guest with us. With immense pleasure, let me invite our speaker of the day, Dr. Juxi Leitner, the co-founder and managing director of LYRO-Roboticists. He has extensive experience in robotics, AI, and entrepreneurship. He started his very first venture at the age of 15 and has spent the better part of the last 2 decades in research and academia with short stints in industry and a year at European Space Agency. We are extremely happy and blessed to have you here with us. Now we have the stars of our session, our participants. You are the one that motivates us to conduct all these programs. Your support is our fuel to move on. So I welcome you all to our grand event, Droid. Once again, I welcome you all to Droid 2 as well as to the second chapter of Robotics Around the World. Welcome all. Now let's dive into the session and lend our ears to our esteemed speaker. Over to you, sir.
Thank you. Thanks for the introduction. Can you hear me?
Sir.
Can you guys hear me? Perfect. I'll try to get the screen sharing going again. Let's see. There you go. Perfect. Wonderful. Thanks for the introduction, and thank you for having me here. I'm really excited to present what we're doing here, but I'm also very excited to get a lot of questions from you guys, trying to understand what we do, and really sort of, as was mentioned, like trying to understand what the first steps are to getting robotic systems into the real world. I'm Juxi Leitner. I'm the co-founder and managing director here at LYRO Robotics. We are based in Brisbane in Australia, where it's just getting close to midnight. But I'm really, as I said, really excited to and hope that you guys will get something out of this one. I'm focusing my talk on how to get robotic systems from the more academic research world into the real world, into getting things done that need to be done. And that's really one of the steps that, especially if you're in an early stage of a roboticist, is something worth considering. Historically, there was 2 options. You can go into academia or you can go into industry. I think it's starting to blur a bit these 2 worlds, which is good, which means that we get a lot of more high tech and latest research going into application products. And that means we can help more and more people out there. With that, let me just give you a quick background of where I'm coming from. I've been in academia for a while. As mentioned, for the better part of the last 2 decades, I've been working on robotic systems, and particularly I'm super excited to get agents and create agents that can interact with the world, that can see the world, that can understand what an object is, that can understand how to manipulate and grasp an object, even if they have never seen it before. And that's really exciting. And for me, one of the very exciting things that I see in students is that nowadays people talk about WALL-E and Baymax, whereas when I was younger, people were talking about Terminator and stuff like that. So it's nice to see there's a bit of a trend towards more robots that do good. And what I'd really like to do, and what we do at LYRO, is really trying to get hundreds of thousands of robots out there that are smart enough, that can grasp the things, that can interact with the world, that can become smart enough to deal with the uncertainty in the world. And that is really the core behind creating robots that see and interact. There's a lot of work going on that is focusing on creating robotic systems that can, physically touch things in the world. And it comes so natural to us as humans. So sometimes the question that I get is, why are people doing it and why is it so hard? It is a critical and crucial step to create embodied intelligence. To interact with the world is a crucial part of all the robots that will come out in the next decade. And I'm very much an optimist, and I believe that thousands and thousands of robots will be out there in the world doing useful tasks for everything. And so that's really sort of where I'm coming from. My background is actually computer science. I studied computer science in high school and started being a programmer before swapping over to programming not just something in the digital world, but turning that into something that is interacting in the physical world. So that's really sort of my background and the thing that drives me. The talk has sort of like three almost separate threads. I'm trying to combine them, but it's basically a combination of what do we do at LYRO? What is the product that we're developing at LYRO? How has the research that we've done before influenced what we've done? What is the science behind some of the products that we're developing? And how did we transfer that technology from being a nice paper and a nice research outcome, a nice experiment, into something that actually performs a useful task and performs like a product would, like a customer expected to do? And then for those people interested in potentially doing their own journey into the startup world, what are sort of the lessons learned and what are the complexities of creating startups that are based on one hand, very leading edge, fundamentally new research and what people call deep tech? And what are the important issues that relate to hardware in transferring startups? So there's a slight difference to a software startup to a hardware startup. And I want to just highlight some of the lessons that we've learned over the last 2 years while doing LYRO. So let's just dig into it. At LYRO, we're creating intelligent picking and packing robots. The picture there on the right is a depiction of what we expect our robots to do in the near future. They are robotic systems that can help in the supply chain, and the supply chain is really under pressure right now. So we're really interested in getting robotic systems out there that can handle materials, that can handle objects, that can handle items from an e-commerce point of view, from an agriculture point of view, from a manufacturing point of view. LYRO was founded in 2019, and together with Nicole and Norton, we started that as a spin-out from the Australian Centre of Robotic Vision. We have a nice mix of roboticists as well as mechatronics and mechanical engineers. And we came out of what we sort of saw a specific shift in the mindset. And we entered the Amazon Robotics Challenge, and we won the Amazon Robotics Challenge in 2017 by a team that I led in the Australian Centre for Robotic Vision. And not just did we score better, but we were the only team that created their own robot on that specific challenge for the 6 months that we had to build that robot. And that really showed that the fundamental research that we've developed for like 7 years before that can be turned into something that works as a system. And to those of you that have had the experience of building robotic systems, or at least interacting with robotic systems, you understand that there's a whole systems challenge behind it. It's not just one part that needs to be perfect. All these different pieces need to actually work together. And for us, that's what was the pivotal moment that allowed us to take that step back and say, actually, we haven't just created like tiny pieces of world-leading research. We actually built a system that can work together and perform something really useful. And we then started looking at what is it that is extremely useful to do for a robotic system right now. And that's when we landed on the supply chain and the problems that were arising in the supply chain, even before the current COVID situation, which has obviously made everything a little bit trickier to source parts, and the whole global supply chain of parts moving from one country to the next has obviously been affected by that. From an Australian point of view, the security and safety and reliability of that supply chain is very critical, not just for us as a country, but actually also for the market. Australia is a very large exporter of agriculture, and just in agriculture alone, there's more than 26,000 jobs right now that are being unfilled because we don't have the labor force here. And most of the time, we either get transient labor force, as in like backpackers from Europe, or Pacific Islanders to come here to perform the picking and packing tasks in the field. At the same time, even before COVID, this was something that was sort of growing. There was an increased interest to reduce the amount of people working on physically touching produce, and obviously e-commerce was a growing interest where similarly the supply chain will have a significant change to happen over the next decade on how these products get into, from where they're being produced into the hands of a customer. And that's really something, from a context point of view, that really requires thousands of robots. It's not just one robot that can actually solve this problem. We don't have one robot that can do this job of 26,000 people. And that really is one of the core drives for us at LYRO, is we need to build thousands of robotic systems that do physical tasks so we can ensure that the supply chain is reliable, secure, and safe. So what we did over the last 2 years is we designed, developed, and deployed what we call the world's first fresh produce pattern packing robotic system. If you say that 5 times in a row really fast, it will just mangle all up. But what that actually means is you have one robotic system that is the same robotic system performing similarly tasks without the need to reprogram. So compared to other robotic systems, we basically don't reprogram whether we're packing up nectarines on the top, sweet potatoes in the middle, avocados in the bottom, or even punnets of, in this case, cherry tomatoes. That's all done with literally the same hardware and the same software. And that's really the core difference to existing mechanized solutions and some of the automation solutions that people are currently exploring in the space. And this is really from us as researchers, from a robotics point of view, is really what we want to build. We want to build a system that is modular enough that can deal with a lot of different tasks and a lot of different problems, but we don't have to change a lot of things to go from one problem to the next. And we use our backend, which we call LYRO Machine Intelligence, which is really the software behind these capabilities, and the software that combines all parts, as I said before, in the system that really provide those benefits to our customers. And one of the benefits that's obviously very critical is to increase the throughput while not having that reliance on labor. As mentioned before, there's a massive problem there. The second thing for our customers is their operations are run like they are being run. And yes, you can change those operations, but you would love to have something that is really plug and play. That's something that we can install in an hour and start having the robotic system there. And our robots can be installed in less than an hour. We've done this a few times now. And it's really something that retrofits existing operations, which really allows them to quickly change over from not having a person there to having a human there, a robot there, or from one fruit changing over to another fruit, because for the robot in the end, that does not matter. And thirdly, one very critical part is also we offer a pay-as-you-go option or robots as a service model, which provides savings to our customer from day one because they don't have to do the capital outlay, which has currently hindered robotics deployments in agriculture, because if there's a significant capital outlay, you have a very small market that can actually tackle. And so that's really what LYRO Machine Intelligence brings behind it. It combines these, what I call the brain, the eyes, and the hands, the robotic vision, the machine learning, and the robot grasping, into one coherent software package that we can put on like literally any robot out there to become a smart enough system to understand the object that's in front of you, how to pick up the object, and where to place it. This is a robot that we built. This is the robot that I mentioned before that can tackle quite a lot of different objects, whether they're fresh produce, whether they're e-commerce. In the end, for the robot, it does not really matter. So that's where we are right now with the product. And what, again, is critical is, and I guess that's one of the first lessons learned, is if you talk to customers, it is not important what technology you're using. To customers, it is important what the features are, and it's very carefully, we need to be very careful about what we talk about features, because as engineers and roboticists, we talk about features like, oh, it's a deep neural network that does segmentation, or it is a behavior tree that makes a decision about what the next steps are to do. For a customer, that's not what features are. For a customer, features are that we can precisely place the object, that we always find a very good grasp point, and that we can offer additional services and additional features to them, which they currently also get from people that are doing it, which is quality assurance, like looking at it and seeing if there's bruises, for example, on the items that we're picking up. And that is very crucial for developing a product. The other thing, as I briefly hinted at, for LYRO machine intelligence, it really doesn't matter if you're picking up e-commerce items here on the left or fresh produce on the right. What you can also see is there's different tasks. The one on the top is basically you're trying to fill a box with mangoes. It's kind of like a Tetris problem. If you actually look at the avocados on the bottom, they have predefined positions that you need to be placed on. And on the left-hand side, you can do tasks that are, separating different items. So basically, it's a sorting task. And we can do the opposite, which is a kitting task, and putting various different objects or specific objects from a box into a cardboard shipping box. And again, that's with the same software technology stack. And that's really where the core research that we did comes into play. The other thing that I want to briefly mention is to build 1,000 robots is actually a significantly different problem to building one robot. We've done in the past, over the last 50 years, we've solved robotics problems or automation problems by building a specific system, a specific solution for a specific problem. And we're really good at that. But this does not scale up to the thousands of positions that are currently unfilled. And that's just Australia, right? Worldwide, there's something like 10 million people working in some of those transient labor jobs. And again, there's probably a significant black number behind it, a dark number that we don't really know how many more jobs could be filled if we were more efficient in the supply chain. But to think about producing 1,000 robots is a different problem. On day one, when you're a startup, it probably doesn't matter so much, but it is very important to understand that every decision that you make at the very beginning of your engineering decision for your robotic hardware will have an impact down the track if you want to build 1,000 of them. And so we're very conscious about the fact that anything that is complex and will make our system harder to manufacture is going to cost us in 2 or 3 years time. So we came up with ways to reduce the complexity, which I think is very important. And it's a different mindset to think about, which again, I think is very important to, if you're doing your student projects or if you're doing your academic research projects, you're usually doing a one-off solution. And once you actually go into an industry setting, it's very important to think about, like, how can you scale these things up? How can you make these things happen in broader terms? Because problems out there are very large problems that we're trying to tackle, and we're trying to tackle the large problems for a reason. So I think that's a very important issue. And we at LYRO did very much make that decision at the get-go that we are aiming for building thousands of these systems. So that was really just sort of a quick overview of what we do at LYRO. The next part is a bit of the science behind it. And I think that's potentially something that hopefully more interest will be from your side. So I'm probably going to go a bit slower through this part. And then very quickly at the end, I'm just going to show some more lessons learned. So one of the things that we like to do as researchers is to do research. As I said, I was in academia for a while. And usually you start here with the right-hand picture and you're doing some research. You have a robotic system in your lab, you have some camera system, you stick them together, you potentially have some objects in your lab and you're thinking like, how can I make this robotic system pick up a specific item? How can I make the robotic system visually understand what's there, write the control laws, go and pick up an object? And maybe I come up with a very good solution, write a nice paper about it, go to a conference and present it. And then I go to the next problem. Right? As a researcher, that's all you do. You look at the research problem, you cover it, and you move to the next thing. Some researchers think like, oh, maybe all these research that I've done actually could go into a product. But actually what we need to do when we come from a tech transfer point of view and trying to understand how we can transfer the research into a product, we need to actually start with the problem. We need to start on the left-hand side and understand what's the problem that people are facing. What is the problem in our case? Farmers and people in the growers in horticulture are facing in the industry. And we had a lot of conversations with farmers out there. And apart from labor shortage, there's food waste, there's compliance, there's traceability, there's lots of different issues that they are facing these days. But if you come from what is a problem they're facing and what would be a potential product that solves that problem, then you can bring in the research and say, hey, for this product, we have this cool research and that will help make that product more efficient, cheaper to deploy, just more cost effective on a scale. And that's really the way that I think we need to address tech transfer. And I'm not the only one about that, but I think it's something that when you come into industry or into that tech transfer area, it is important to understand that the latest, greatest, best research might not actually be that missing link to solve the problem that's out there, right? So it's very important to understand that these are two different things, and it's important to come from the right point of view into that. As I mentioned, a lot of the work that we've done at the Australian Centre for Robotic Vision, which was a long-term national research initiative here in Australia, was focused on building modules and capabilities. And that's where I was as a postdoc. I came to Australia in 2014. I worked there as a postdoc and built up the robotics manipulation lab. And we built lots of these different components. And sort of in the picture, we built lots of little parts. Those parts don't necessarily need to work together. And some of those parts are focused about the AI systems that allow decision making, or the AI systems that allow quick training of computer vision algorithms. Some of them are computer vision algorithms and new ways of using deep learning for grasping. I'm going to talk a bit more about that one. But we also built mechanical systems, built gripping devices. We physically 3D printed parts and checked out what sort of geometries work differently for picking up different items. And all these parts we sort of developed somewhat independently, right? So some students worked on one thing, the other students worked on the other thing. The one thing that really brought these things together, and again, we didn't use all these parts that we developed, but a lot of these parts were brought together during the Amazon challenge, because we had to build a system. We say, hey, actually, that technology about building grippers is really helpful. That technology that makes us understand what we're picking up is actually really helpful. That way of integrating machine learning AI strategies is actually really good, because it allows the robotic system, which needs to operate autonomously, to deal with that uncertainty, to deal with a new environment where we're getting like new items thrown at. But again, it's sort of coming from a different point of view. So that is sort of, I guess, the difference that I'm trying to make here. And so just to focus a bit on the research work that we did, during the Amazon challenge, we really integrated these things together into this specific robot here that we call Cartman for Cartesian Manipulator. If you look very closely, you can see there's an X, Y, Z axis that is like a gantry system that allows the robot to move back and forth. It is not a very polished product, because it was meant to be for a one-off for a challenge. It was built by students, and it was built over the course of a bit more than 5 months. We built that in-house. As you can see, also with all the cabling, we did all the electronics and everything in-house. And it is really meant to be a picking and packing robot that can deal with that specific problem that Amazon gave us. What we did, somewhat by accident, was we actually built a very modular system. And that really was coming out of us at the beginning of the problem, at the beginning of those 6 months, not really knowing what the final robot would look like. So on one hand, we had AI vision modules that sort of we trained separately, and we had run on separate computers that would deal with picking up, sort of segmenting out pixels in the image that would make a differentiation between the teddy bear and the pack of wet wipes that the robot is currently holding. But that system wasn't really required to know exactly what the robot would look like, right? So we modularly approached that because it allowed us to work in parallel and allow us to work through during those 6 months on lots of different applications. Similarly, we had 2 cameras, and we actually at some point had 2 completely different camera systems. And again, that's coming from stemming from our idea to like separate these things out at the beginning. Similarly, if you look very closely, the robot actually has a second gripper. Right now, it holds things here to the vacuum suction that points downwards, but actually at an angle of like 60 degrees, you actually see a black motor further up there. And that's actually where we had a two-finger pinch grasper to pick up things like the toilet sponge that you can see in the background as well. And so again, that modular design sort of happened by accident, but really allowed us to explore a lot of different avenues at the same time. But what was actually really crucial was that while we built all these modular systems, we came together and integrated that system very often, not just at the very end when we needed to, but actually almost every week or at least every fortnight, we had a demo where everything was going to be put together. And it didn't work perfectly, but it really showed us out of all these modules that we built, which ones are the ones that look more reliable or more going into the right direction of what the final challenge will be. And that really helped us to, on one hand, explore lots of opportunities, but also build a system that in the end worked. And we didn't have the problem of final integration happening only on the final day. So the Amazon challenge, I hope some of you might know what it is, but generally speaking, it was a research challenge by Amazon where the task was similarly to a task where Amazon is very good at, which is order fulfillment. And you had 2 boxes that were called shelves. And you had, in this case, what's called a stowing task. So you get a box of random items. Some of those items we've never seen before the day of the challenge. So we had about half an hour before this to play around with those items. And as you can see, this was not perfect, but it does somewhat the job. The point of this task is like to pick up the item, understand what the item is, and then place it into those 2 boxes. This is one-time speed, so it takes quite a bit of time. I'm just hoping I can potentially show the use also of the other gripper there. As I mentioned before, this is an autonomous system, meaning that all these students that you can see here and potentially nervously jumping around, that is because they're not allowed to touch anything once the robot started working. And some of those are very challenging pick points because there's items leaning against the wall, which is very tricky for a robotic system to deal with. And so sometimes you get quite frustrated as a researcher there, and you really want to help the robot, but part of the rules was that we couldn't do it. Right? So that's the 2 different gripping devices that you can see. This is the vacuum suction on the very end. At the end, you see the 2-finger pinch grasper. And so this is, for example, how we dealt with items that were leaning against the wall. It's maybe not the most careful way of picking up a notebook, but it does the job. So that's one of the tasks during the Amazon challenge. The second one was basically the inverse of that, where you would try to pick up the notebook here into one of 3 cardboard boxes to perform an order fulfillment task, and pick up the DVD, pick up the notebook, and stick them into the right boxes, which they can send to the end user, right, to the consumer. The other thing that I want to talk briefly about is the vision system is obviously a critical part, and how do you train a vision system to pick up items, especially if it never has picked up these items in a run before. So we use 2 different ways. One is called a stock standard supervised semantic segmentation. We had a different approach, slightly different approach that allowed us to do this very quickly, and we could train up just a handful of images. And we also tried a deep metric approach, which is a totally unsupervised learning approach. They were more or less the same, and we in the end stuck with the supervised approach because it allowed us to train the system quickly. And that's, before going in there, I want to show you sort of the other thing here. To train the system quickly, there's lots of different ways to figure out like what's the best way of training these neural networks. And that goes back to the systems problem that I mentioned before. Yes, you can do all of this autonomous, but actually during that half hour that I mentioned before, we could actually have people touch the objects. So this is 2 of our students throwing items in front of the robotics camera, like of the one camera looking down from the robot. And you can see those two kind of like having a Formula 1 pit stop almost, like throwing in items, flipping them around, and you can see other people, saying, yes, we saw the object. Yes, we build a mask around the object. And yes, that's good enough. Twist it around, turn it around. And then furthermore, actually provide a bigger training set through data augmentation tools and other things. So that's one way. I think the other thing that we did differently, which is take a step back and say, what is actually a good way of training a computer vision algorithm? And so there's lots of different algorithms that you can use, and there's lots of different metrics that you can use. What you in the end want to do is like you get this as an input image, and you want to have on the right here all these labeled output images where you have pixels that belong to the right object. If you look at literature, there's lots of different metrics, as I mentioned. There's precision and recall curves. There's an intersection over union that a lot of people are using, and there's F-scores. But looking a bit more closely at it, for us, the computer vision segmentation part was only part of the problem because the segmentation was not the end goal. The end goal was to pick up an item and actually pack it. So therefore, we actually looked at what is a better score that would represent something that is more useful for us. If you just look at the very bottom, obviously, if you get all the pixels correctly, you get a 100% score, which is what you want to achieve. But if you're not 100% correct, different scores will give you different results. So like, for example, here we have too many pixels. And if you look at the IOU score and F scores, they're actually very much the same thing as the F scores and the IU scores over here. But in this case, we only have half of the pixels correctly identified. But if you're now trying to pick up the object, the image on the right is actually providing you a lot more useful information, because if you try to pick up the item with any of those pixels, you have a significantly higher chance of picking up the right object. Versus in this case here, if you pick any of those pixels on the right-hand side of the left image, the green, you're actually picking up the wrong item. And that is something that the F-score, for example, does not represent. In this case, we actually have a high F-score, which would say this is a bad classification. So thinking about the problem slightly different allows us to actually structure our thinking and structure our learning algorithm. And that was really core of how we built the system that was significantly faster in learning these items, and then obviously was more successful than any of the other approaches. This is another work by Doug, who was one of my PhD students at the time. And he realized that, yes, it's nice thing that we can actually pick up objects, but how can we pick up objects that are either geometrically changing all the time, or moving around, which also provides uncertainty. So how can we deal with this uncertainty of our perception system and still have a robotic system that can pick up these things? We call that GGCNN, which is a graph generating convolutional neural network. In the end, it provides us something that we call reactive grasping. And the neural network allows us to train a model, a neural network model, which would give us not just a quality, what is a good grasp point, but what is the angle that I want to pick up with? So if you look at the CoFounder there, you can have an angle and you can have a width of closure. If you have these three informations, you actually know where you need to go in the image. You need to know what the orientation is. You need to know when you need to close. That's actually all we need. If you actually put that in a loop, you get to do this with robotics. So you can do this on a robotic system, even if your items that you're picking up are moving, because the position all of a sudden is less important because it keeps updating during your image classification process. And so this is actually a really interesting tool that we now use in a lot of our work, and actually lots of others have used it in the last 2-3 years as well, because it provides a fundamental, like a low-level capability to a robotic system to pick up an item if it's moving, to pick an item if you don't know the geometry, to even pick an item if you don't know what these items are. So this robot has no idea what is in this pile of objects. It just fixes and navigates to what it believes the best, most likely to succeed grasp point is, and picks out an object from that point. And so that works really well. And I think that's another really interesting technology on one hand, to build for research, but this is also one of the core things that from a tech transfer point of view makes a lot of sense, because you will have to deal with uncertainty. You'll have to deal with lots of new and novel items that you've never seen before. And so it's very, very important to understand that you can pick up things even if you haven't seen them before. Let's see. Next slide. So as I mentioned, there was lots of different modules and lots of different parts, and they focus on specific parts of the problem, whether that's grasp synthesis, whether it's vision in loop grasping, grasping with intent. Done all these modules. We have done reactive grasping, just like I showed you before, but we've also done like lots of different other approaches to reactive grasping over the last 15 years. But now what we do at LYRO was really to focus on not just reinventing the wheel. We were taking some of the research, but really trying to build systems into that and focus on more things that researchers have not focused. So for example, how do I ensure that while I move the object around in the air, it doesn't fall out? How do I measure that? How do I understand that things have fallen out? How do I then reduce the risk of it falling out? That's something that not a lot of researchers are looking at. But obviously from a robotics product point of view, that is crucial and critical for us to have. Similarly, how do I pack something efficiently is something that in motion planning people have done on a more theoretical level, but actually in a physical system, there's not a lot of work out there. So that was something where we as LYRO put a lot of R&D efforts in, like how do we build these? And then again, as I said, from a LYRO point of view, the point is to incorporate all these things together and to actually create a final product that can work along these lines. And again, that's sort of, I guess, the takeaway here from a LYRO point of view. So tying that in with what I said before, this research and transferring of that research into a company, lots of different ways of doing it. And what I'm saying here and the lessons I learned, obviously, from my experience, I hope they have some value to all of you out there, but they might not be one-to-one exactly the things that you experience. First of all, a lot of people talk about startups, but it's, I think, a partly misunderstood concept, and it's not always clear to everybody what that means. So I think this is a very good definition, and particularly startup is there to undertake and find new ways to scale business models, right? So the main point about a startup is not to find new technology and develop new technology, it's actually to find new business models. And if new technology can help, that's great. But it's about what is a good business model? What is a new way of selling things? What is a new way of entering a market? And for example, in our case, robots as a service and agriculture are two things that have not been put together. And it's a different way of validating that we can get these things out there. And that's really what the startup part of our company is about. At the same time, you also talk about deep tech or hard tech, which is really sort of the other side of the coin. And it's basically, how can we use this fundamental research and provide these technology solutions that really allow us to do these new and validate these new business models. So I think they work very nicely together, but they're not the same thing. I think one thing that was very important for us is trying to approach the problem slightly differently. So in the Amazon Challenge, we built a complete different robotic system that was actually simpler and articulated on, but again, by thinking outside of the box, in this case, actually inside the Cartesian box, we did build something differently, and that actually worked. I'm not saying it always works, but it actually opens the solution space if you just try to think about problems slightly differently. Similar in the research side of things, if you think about a problem differently in terms of what your scoring is for your vision system, you might actually find a better way of building a system that can classify things faster or better with less resources. So trying to play around and trying to think slightly differently, slightly outside the box really helps with that. And similar, like Juxi was one of the first solutions out there that actually didn't just give you one grass point. It actually provided you a heat map of all possible grass points that come out of the depth image right now, which nowadays people are using, but before Doug did it in 2017, 18, not a lot of people have looked at that. And so I think that's, again, something like, it was somewhat obvious in hindsight. People hadn't done it before. And I think that's a critical, important part, not just of building a good academic career, but also to understand how to transfer parts into a startup and transfer part into a tech transfer pipeline, if that's what you want to do. I think that is a critical part. AI is an enabling technology, but it is not the product. Data is not the product. Data is not the value of your company. What you do with the data, yes, that might very well be what gives the value to your company, but by itself, AI is not the product. In our case, the product is a physical box. We install that box at the farmer's site, and whether that's AI, whether that's deep learning, whether it's machine learning, or even a hard-coded system, in the end, for the farmer, that doesn't matter. They want to have a certain amount of throughput of produce happening, and in the end, it doesn't really matter what the underlying technology is. And so I think reframing, again, I think that's the point I'm trying to make again, like reframing your mindset and saying, well, actually the technology, if it helps me to deliver, perfect. But the core problem that we're solving is, can we deliver a product? Can we deliver value to our customer? I've touched on this one before, but large problems are large for a reason. There's usually a large underlying cause. So we need large solutions and scalable solutions that can really help with that. So I think that's another critical thing that, you know, we learned over the last 2 years. It's like, yes, we could build a specific solution for carrots, and we can build a specific solution for a banana. But then we are never gonna solve a large enough problem, because we're, you know, solving one niche after the niche after niche, and the problem just grows faster than we can find solutions, right? So you need to come up with ways that your solution can actually catch up with the problem. And I think that's critical and important as well. I've hinted at one as well before. Sometimes it's not so much a problem of like being wide or narrow. You can actually do both. Like by a modular approach, it allows you to have a robotic system that is actually going in the direction of embodied intelligence, but you can still focus on one specific niche, and you have specific modules that you can put, you know, either on top of each other in sequence or in parallel to solve a specific problem. But then you take those modules and you apply them in different settings as well. And so I think that's something that robotics provides you, and I think it's an interesting way of thinking about it. And I think that's something we should strive for, solutions that are both wide and narrow. And I think that's both on the science side of things, something that's interesting and we can achieve, as well as on, you know, a tech transfer product point of view. Oops, that was one too many. And sort of the last thing is, a robotics startup and a tech startup are hard, and there's lots of people out there that, you know, are maybe trying to do it, but it can be sometimes a very lonely challenge or lonely journey. So it's very important to talk to people about it. I think some people are too precious about their ideas, but yeah, on my end, I'm trying to talk to a lot of people that have ideas and want to do it. Not just tell them like it is a hard journey, but really actively trying to help them, because the quote that, you know, was IEEE in 2019 is that the startup is a marathon, the robotic startup is a decathlon, and there's not a lot of roboticists out there. In the end, we're still a small group of people in the world that understand robots. So we should work together, and I think we all understand it's a hard problem that we're trying to solve, but we should really work together and try to find ways that we can solve the large problems together. With that, I want to sort of finish here. Say thanks again for having me, and feel free to reach out. My email address is there. You can find me on Twitter and LinkedIn and stuff like that. So feel free to reach out. I'm more than happy to answer some questions now, or if you don't have a question now, feel free to, but come up with a question later, feel free to reach out. So thanks for that. let me know if there's any questions.
Thank you, sir. Now it's Q&A section, and participants, please feel free to share all your doubts and queries in the chat box or by unmuting your mic.
So I don't, while I do the screen share, I actually don't see the chat box. So if there's chats, question in the chat, maybe please, if somebody could just read them out to me, that would be helpful. Thank you.
Yes, sir.
It's a good question, and we don't know what the answer is going to be, right? But I think we all have opinions, and you know, by being part of creating that future, we can shape it. I think it's going to be a very utopian, very positive future for us. For us at LYRO, one of the main driving points and core drives is to allow people the freedom to not do what we call dirty, dull, or dangerous tasks, or tasks that are degrading to the human spirit. I don't think people should need to do those things. And I think we have the technology to help people overcome some of these problems that arise from them. That doesn't mean that people won't do it. Some people might still choose to do it. And there will still be a requirement for humans, but I think we can strive for a better world with that. In terms of, and that's just from my robotics point of view, in terms of AI will really, I think, go through a lot of areas of society and through lots of different parts of our daily lives, and similar as computers and mobile phones have done over the last 10, 15 years, right? So they haven't just changed one thing, they've changed a lot of the things that we do on a day-to-day basis, whether it's talking to people all the way to selling stuff. And similar with computers, similar with AI, we'll see something that happens on the data that we collect allows us to do things more efficiently on human interactions, all the way to agriculture, farming, machinery, manufacturing, recycling. I think there's a lot of opportunities for AI to do something good, and I think for me that's a very positive outlook. I think there's a lot of positive things we can do, and obviously we don't know exactly how it will look exactly, but we can build parts of it. I think that's the exciting thing for me, being part of building that future. But also, I hope for some of my students, when I worked with them, was to show them that they can build that future. And actually, most of my students that have worked on the Amazon Challenge or have done a PhD with me are currently actually not in academia. They're working for startups or companies, and they're building, intelligent machinery, intelligent software out there to perform tasks from mining industry all the way to agriculture. And I think that's, for me, that's very exciting, because I know that these guys and gals are building cool things and try to make the world a better place. So for me, I think there's a lot of opportunity to improve our quality of life by having AI systems out there. I mean, there's, again, similar to the answer before, I don't know exactly what will happen. And I mean, there's always going to be local effects and global effects, right? So, or positive effects on one hand and negative effects on the other hand. There's no free lunch, right? Nothing comes completely for free. So I think there's a potential that of misusing AI, and privacy, I think, is an important topic that we've seen so arise out of the use of data. And so I think there's certain things that we as a society need to decide what AI can and cannot do, and what data it can and cannot access. I think that's something that, you know, different societies and different groups of people might decide differently on. But I think it's something that we should have a conversation about. And at the same time, we also need to explain to people why the AI is doing certain things and why we want the AI systems to do specific things out there. And I think that's, for me, the other side that sometimes gets a bit forgotten in this whole conversation is we need to educate people to understand technology and understand the impacts that technology will have on their lives. So I think that's something like education and soft skills is something that we need to, you know, teach at the same time as like just building AI, so that people, you know, can have so the counterpart and the interaction with people that are not just in that field. So again, I don't know exactly what the future will hold, but I mean, there's obviously we've seen trends where some of these systems are being misused, and so I think that is something that's happened with all technologies that we adopted, and it's just something that we need to be aware of and something that we can, you know, tackle up front if, as I said, have enough education, enough people understanding what's going on and understanding potential, you know, drawbacks of these systems so we can make informed decisions. Yeah, I can't tell you it's an easy job, but it's a different job, but it's sort of somewhat similarly to managing, you know, your own research and then managing potentially working with students. So I didn't become, you know, the CEO of the company and all of a sudden I had to learn how to manage people, right? So I was managing people before just in an academic setting. And there's some similarities. So I think that helps. And similarly, you know, organizing events like that or, you know, student groups, that's all skills that help you understand what it is that entails managing. And I think one of the important things there is that sometimes there's no perfect solution. There's only good solutions, and there's, you know, one solution that you need to make a decision on, even if you know it's not the perfect solution, because you as the manager and CEO, you have to make the decision so all the other people can actually keep doing their job, right? So I think that's one of the harder things to sometimes make the tough decisions and make a call based on not having all the right information, because information keeps changing. You know, I don't know where the market is going to go tomorrow. I don't know where border closures might happen. So when we started, COVID was not a thing. And so in the last 2 years, that has significantly impacted the company. But you need to be able to react to that. So I guess back to your question, there's different types of things that you need to manage. And so the engineering side, I think, is very similar to what you do in academia and you know, working with groups there. But as a CEO of a company, you actually have a lot of other things that you need to manage or at least interface with as well, whether it's, you know, lawyers, accountants, business people, marketing people. So it's a broader scale. And again, it doesn't mean you have to know all of that. You just have to find the right people and people that you can trust to make the right decisions, right? So a lot of it is also delegating and not just purely, you know, giving instructions. It's giving people the freedom to make choices themselves, because you will not know everything because there's too many things going on at the same time all the time. So I don't know, that was a bit of a long-winded answer. I hope that sort of answered most of it. If not, just post it again and I can try to hone in on a specific part of that problem. That's a good question. I can't tell you exactly how far away we are, right? But so I worked on a humanoid robot during my PhD, so about 12 years ago, and that was a European Union project, and that's been going on before I started my PhD, and it's still going on. And building a humanoid robot is a very complex thing on the mechanical side of things, on the electrical side of things, on the software side of things, on the sensing side of things. And just getting all these things from an engineering point of view ready and working is actually a significantly hard challenge. I know that Tesla announced that they want to build a humanoid robot, and I really wish them all the best of luck, but I think it's a bigger problem than they expect it to be. So I'm dubious that there will be prototypes out very soon. The other part of the question was actually humanoids that are like humans, and I think that's a bit harder to understand what your question actually means with that. So for example, there's robots out there that obviously can lift parts that are, you know, stronger than humans are, right? So like industrial robots can lift things that are significantly heavier than what we can lift as humans. They are a lot more reliable as well. So I guess the question is, what do you mean with they can be like us humans? You know, when do we see a robot that can, you know, go into the kitchen and make me a cup of tea? Probably that's going to take significantly longer than people expect. But, you know, robotic systems that might look humanoid and perform tasks like, you know, cleaning the floor, like Roomba, but humanoid looking, or, you know, disinfecting certain items in, let's say, medical areas. We might see a lot earlier than that because the systems and the way they interact are a lot more structured than, let's say, a kitchen, because everybody's kitchen will be completely different, right? So we don't know where the cups are, we don't know where the mugs are, we don't know where the sugar is, we don't know where the tea is. We might see the kettle, but we might not know how to operate the kettle because every kettle looks slightly different. So that's a really, really hard problem. And I think there's a lot of cognitive research, neuroscience research that still needs to happen for us to understand how we do that, so we can actually reproduce that in robots, right? So I think the second part of the question, like similar to human reasoning and similar to using human capabilities, is really, really hard to answer and really hard to draw a line where that is, right? So as I said, like I don't want to say a date because it's most likely going to be wrong. So I'll leave it here. Yeah, so that's a good question. So we currently are having interns that are basically doing virtually, like over Zoom and remote operations. They are actually probably more on the business side of things than the engineering side of things, because it is still a bit tricky to operate a robot over an internet connection. So that's something where we probably prefer people to be here. But that said, we have to be flexible, and you know, especially sort of with border closures potentially keep going on for a while. There's ways that we need to operate like that. And as I said, we currently have interns that are working with us, but most of so we have interns here in Australia that work with us, and they work across all areas, engineering and so forth. But the ones that we have remote tend to be focusing on business, marketing, and sort of the other aspects where it is not critical to be in front of the robot. Yeah, very good question. I think it's a very important question. So we are currently focused on you called it industrial applications, but yes, there are specific parts of a subsystem of the supply chain that we're currently focused on. The technology that we have developed and that we are continuing to develop can be applied to lots of different things. And one of my co-founders, Nicole, she's actually working across psychology and engineering. So she's very much focused on how to get these robotic systems working closely with humans. I don't think surgery and that particularly kind of medical is something that we will do with LYRO, but we might be doing things around elderly care, domestic settings, things where you hand over potentially a cup of tea or something to a person, or even work in together with a person, so where the person might be picking up something and you pick up something as a robot. So that's something where we definitely see a lot of potential for our technology. It's something though where, at least currently as LYRO, we are looking to partner with other companies. So for example, we're not building mobility platforms, right? So we're not building a full humanoid, we're just building hands and grasping systems and potentially arms, but we're not going to build a mobility platform. So that's something where we want to work together with people that are doing that. We also have a partnership with a Norwegian company that actually is building humanoid robots. So that's something where we want to work together with people that are building other capabilities. And so from our interest point of view, definitely aged care, social robotic systems, robotic systems that do cleaning tasks, whether that's environmental cleaning or cleaning in a hotel or in an office building, or eventually domestic stuff is definitely something that we see potential in the next 5 to 7 years. Yes, I'm actually very fond of that. One of my very first research projects was about that. How can we coordinate multiple robots in the same shared workspace? It's actually surprisingly tricky, and it's something that is, if you're doing a product, as I mentioned before, simplicity is key. Maybe for us, we see this as the intermediate step where we have multiple robots working in parallel, maybe not in a shared workspace that we understand as a shared workspace where two hands are actually interacting with each other, but they're still sharing a task and they're still sharing the resources that are coming through. So for example, they could pack multiple orders at the same time, or could even pack the same order if, for example, one robot has certain things but not the other things. So that's something that we see as an intermediate step. But eventually, yes, I would very much like to have robotic systems that are interacting with each other. And so, as I said before, like I was working with a humanoid before, and we actually tried to hand over between a human and a humanoid, but also between a robotic arm, like an industrial robotic arm, and a humanoid. And I think it's something that we will have to tackle from a research point of view. I think there's a few research questions to ask, but it will definitely open another subset of the market for products as well. And so I think personally, I'm very interested in it, and I think it's something that we will definitely have to look at more closely. Probably not for our first product range, but for the subsequent products that are going into the market. And so there's things out there like cobots that are somewhat safe to work around humans, but they can't actually work with humans yet. So I think that's sort of another area that's sort of also very much related to multiple robots in the same space. Is a bit simpler, but very much mathematically a similar problem to a robot and a human working in the same space. Yes, very good question. Yes, we use quite a lot of different frameworks on the robotic side. We do use the robot operating system, ROS, as a middleware. We do have a few parts on the hardware that are not, where there's no ROS interface or ROS drivers, and robot arms that do not provide that. And then we have to write part of that ourselves, like as a middleware. But we do use ROS extensively in our testing and most of our products to have some ROS interface. Similarly, on the vision side and deep learning side of things, we use quite a lot of open source tools and frameworks that are out there, from PyTorch to Jupyter notebooks to image labeling and classification systems out there. We use open source database stacks for your standard SQL databases, all the way to more schema-like systems and time series information. So there's lots of different tech stacks that we have, which is always a challenge, because there's usually more tech stacks than we have people. So, but it's something that comes with the nature of a robotic system, where you have a lot of different systems. So ROS is a really nice tool, because it allows us to interface between lots of different other tech stacks. So we're a strong supporter of ROS. We're still using ROS 1 and not ROS 2, though. We have had a few issues with ROS 2, but we hope to swap over to ROS 2 at some point in the near future. If there's more questions, there's my LinkedIn contact, and my email address was somewhere on that slide too. So if there's other questions, feel free to email me after the talk.
So I hope everyone's clear and happy with the session. Thank you, sir. That was indeed a wonderful and very informative session, and I'm sure that it has ignited all the young minds out there. So, and now before we conclude, I request everybody to switch on the cameras and pose for a snap.
While we're waiting for everybody to turn on the cameras, again, thanks for having me. I really hope that you got something out of it. And yeah, feel free to reach out if you do have any questions or concerns, or just want to run an idea by somebody. Just feel free to send me an email.
Okay, sir. Thanks to all. And now I invite Ms. Devinanda to deliver the vote of thanks.
A very warm good evening to one and all. It's my privilege to have been asked to propose the vote of thanks on this occasion of robotics around the world. I, Devananda SK, on behalf of the entire family of IEEE FISAT SB, would like to mention our deep sense of gratitude to Dr. Leitner sir for such a wonderful session. We're extremely blessed to have such an eminent, experienced and enthusiastic speaker. Thank you, sir, for sparing your valuable time with us, motivating and encouraging all the robo enthusiasts. It gave us deep insights into the topic and cleared all our doubts regarding the same. And I'm pretty sure that everyone enjoyed and utilized this session well. Please do accept this token of love and appreciation from our part.
Thank you.
Next, I would like to thank IEEE RAS Kerala chapter for giving us such a wonderful opportunity for interacting with such inspirational roboticists around the world. I would also like to thank our branch counselor, Mr. 𝗧𝗶𝗺𝗲, for supporting and guiding us. Now, I would like to express my love and gratitude to all the students and volunteers present here for participating in this igniting talk session. Thank you all for joining us today and making this a successful event. Wishing you all the best in your future endeavors. Thank you.
Thank you, Devinanda. A feedback form is attached to the chat box. All participants are requested to fill the form before leaving the meeting, and the form will be active only for 10 minutes. That marks the end of our session. Thank you all for joining us. Stay tuned. We will be back on the 4th of September with Mr. Robin Tommy, Rapid Lab Head at TCS Research and Innovations. Join us with an interactive section on social assistive robot for special education. Until then, this is Anu signing off. Good night, everyone.
Thank you again for organizing. See ya. Have a good night.